Hey everyone, in this video we're going to take a look at another implementation of swarm intelligence using batch files. We're going to use GPT-4 Omni, Opus, Gemini, Llama 3 70b all work together from a common understanding, writing a common understanding. So it's a collaborative, cooperative, and iterative approach. And then we extract the code that they generate and write it to file. To see how this works, let's go ahead and run our start.batch file. This is for Windows, but you can do it for macOS using a shell script. Same difference. When we run the start.batch file, you see that multiple command prompts are initiated, agents, each one representing an agent and a utility script. So this is what we see. We have GPT agent initiated, router agent for Llama 3, Gemini is running, and Claude is running with Opus. We also have an additional helper script that is going to trim responses so that we save on tokens. But nothing is happening right now because they all feed off of this response.txt file. So we have to paste in an instruction series. They're checking this response.txt every second. So I'm going to get this instruction to build a Pygame world simulator where different life forms live and interact with one another. Let's also add use only Pygame generated assets. And let's cut this and paste it into response.txt. As soon as we do that, since they're checking it every second, we are going to see them responding, as you can see. Gemini is not using streaming responses, but GPT, Llama 3, and Opus are going to start working at this. And now, as soon as they start working at it, and as they respond, the responses are going to go into response.txt file. They have no memory other than what is in this txt file. And we are writing their responses as in this is a response from AI1 and AI2 and so on. So they're going to actually, at each iteration, be able to take a look at each other's responses. And as this responses accumulate, currently at 20,000 characters, we're going to transfer them to response history. Okay, so that since they're only using response.txt, we are actually limiting the tokens to about 20,000 characters. And when this file, the code files are the responses are transferred to response history, we can run the code extractor. This code extractor.py file, which is going to try to extract. We will see the extracted code. So this is all the code that any agent has written, and now we can actually run them by one. So we're creative, it seems, when they are working with this, and they are still working. We can see them still writing, but we had 5 iterations. So Gemini is done. Here, I believe this was GPT. Llama is done too, but Opus is still going. It's very much the slowest model. We can run the code extractor again to see if we have additional code. Yeah, and let's check out the. And as you can see, they are actually interacting with one another. You can see some of them popping out of existence. Code files for this project will be available in my 1000x masterclass, along with a tutorial walkthrough tutorial video on how I coded this. If you do become a patron, you'll be able to download the project files plus the video. Also at my 1000x Dev Masterclass, I keep adding new content. Each one of these are project files included along with how I code, how I use AI tools to code faster so that hopefully you will be able to as well. In the last year and a half, I spent over 3,000 hours creating 300 plus projects. You can find them all at my website, ecohive.live. And yeah, I'm really excited about this 1000x Masterclass. Let's get back to the code though. Link to my 1000x Masterclass is in the description, but let's take a look at how this is working. Here, let's run the simplest example with GPT-4 Omni to see what is happening. Let me also display this with a diagram. So we have a response.txt file, which starts as empty. And then when we run the batch file, we start an instance of the 4 agents, one for GPT-4 Omni, one for Opus, one for Gemini, and one for Llama 3 70b. But as long as the response.txt file is empty, they just keep checking it and nothing happens. But as soon as we paste in an instruction, don't start typing because they check the file every 1 second, but you paste in an instruction, just write it somewhere else. Then they automatically start generating all at the same time responses, and those responses get written to response.txt file. And then this process repeats, so they get to see each one's contribution to the process. This actually, I found, works better than trying to line them up in a sequential way with some kind of coordinator deciding who's going to go which way. This way we write each responses so they can get inspired from each other. And I think this leads to better and more creative code. So, and at some point we trim the responses and then extract the code. Let's try to run this from just run the single GPT.py, which is one single agent. And when we run this, as you can see, nothing is happening. Let me pull the response.py file here. And let me go ahead and paste and just say hi. And as soon as I say hi, it's going to respond and it's going to stop because, and its response is going to be written to the response.txt file saying this is a response from AI1. Okay, and if I were to here run Llama 3, Llama 3 is going to immediately respond to this. Here we go. In its system message, there's something about a Python script. That's why it's actually hallucinating a little bit. We can run Gemini here. Gemini is going to respond now. Let's see if we don't have streaming for that. Yeah, so see, Gemini is responding to the problem that Llama 3 had actually, which is a hallucination. But at the end of the day, we are writing this response from AI1, AI2, and AI. Gemini is going to be AI4. I just fixed that. So this way they can collaborate. So the idea is that response.txt file is the unifying piece, and the batch file starts a command prompt running each one of the agents separately so they can share a common history. We will have a length checker, which we also run from the batch file. This length checker is going to continually check the length of the response.txt file and transfer some of that earlier history into response history. This way, actually, because since we have like 4 agents, the context gets really large really quickly. So try to save on tokens and also like context limit concerns. And now we're going to have we have a code extractor.py file, which you run manually, which tries to extract any code file that you can find and write it into code files. And this one particularly looks at the response history.txt file. So let's take a look at how we built it by looking at the GPT example. We are using the unified classes. So I have the OpenAI unified.py file, also the cloud unified. These are just, classes I created just to call the API, nothing fancy, but it also has some nice methods to simplify stuff. For example, at GPT, you can see that we can just call the GPT by calling GPT chat and passing a message. And the heavy lifting is done by OpenAI Unified. If you want to find out more about these classes, you can search for OpenAI Unified on my website. And this is the class that I'm talking about. And also a simple, easy Opus encoder. In this video, I actually talk about the Cloud Unified file if you want to check them out in detail, because we won't get into them in this one. But however, we do import the GPT calls class from OpenAI Unified and instantiate that class with the latest model, GPT-4o. And we set its mixed history to 0. So these are not going to inherently have any history other than what they're going to be reading from response.txt file. Okay, so we're going to be manually managing. And before continuing, I do want to say that this is a very hacky approach. I got this idea and I wanted to try it. This might be done better, maybe using threading or async. But even though it's hacky, it also kind of makes things clear, I suppose. So as you can see, we are getting a system message called always strive for the optimal solution given any ongoing conversation. If you're writing code, return all the code in a single code block. Don't use triple backticks for anything other than code blocks, because so that code extractor doesn't get confused. It's the same system message for all. Like if you look at Llama 3, we are using the Open Router Unified because we are using the Open Router for the Llama 3 70b. By the way, each class detects the API key from environment variables, but feel free to add them here as well. So you do have to add their environment variables in each one of the classes, the way it's set up currently. But as you can see, they all have the same system message, and they all have the same check response file. Let's go back to gpt.py. Same file that just reads the contents of the response.txt file, and then append to response file, which appends the response that is returned at the end of the response file. This is how we get this response from AI1. This is a response from AI2, so they can see each other's responses. Okay, continuing, we set a state for the response because since they're going to be checking the response.txt file every second, we do want to maintain a state. So if response.txt file hasn't changed, we don't want them to respond to it again. That's why we set previous response to none. Here we set an amount of iterations. Here in this case 5. We start a count with a while loop. We read the file contents and then we check if there is anything. So meaning this is not empty, or that its state has changed. If that's so, then we get a response, increase the count. We append it to the response.txt file. Then we read that response.txt file. We say that now this is the state currently, and unless another model has written to the response.txt file, then this won't trigger again. And then we sleep for 1 second and continue to do that. And we only increase the count after we have gotten a response from an agent. Okay, it's the exact same thing for Llama 3 and also for Opus, except for that to set the system message, you have to set it as a parameter. So cloud chat class within the Cloud Unified file is a method for that. It's the exact same system message. Other than that, everything else remains the same. For the naming, AI3, for example, is Opus. Okay. So, and then with the batch file, we just simply just start a command prompt running GPT, Opus, Llama, Gemini, and the length checker. We're going to take a look at the length checker here in a moment. If you just want to run one of it or two of it simultaneously or three of them, just feel free to modify this file. So the length checker, again, is going to run in a for while loop, and it's going to check every 5 seconds. It's going to read the response.txt file. We set the max length to 20,000 characters. Feel free to change this. And if the length of the response.txt file goes over 20,000, then it's going to transfer the earlier part of the composition into response history, except it is not for the first line, because the first line is going to be our instruction. Okay, so don't have new line characters in your instruction, otherwise it'll get erased. The reason why I did that, so that in third, fourth, or future iterations, we always keep track of the original instructions so that the agents don't, get carried away into different directions. Now, when this happens, there's another caveat. When your iterations are done, let me go back to actually the previous example. So we had all these, right? As the response.txt file gets filled up, we transfer the earlier portion of the conversation in the response.history. But when this entire program runs and is completed, there's going to be some stuff left in the response.txt, which is going to be the latest responses. So you can actually cut or copy them and then add them to the end of response history.txt. And after that, run the code extractor. You can run the code extractor at any time, and then you'll have all the codes that the agents have generated this way. And the code extractor just opens response history, and using regex tries to find any piece of code that is in between triple backticks or triple backticks Python, and then writes them in an enumerated fashion under the code files. So yeah, and it also creates the directory if it doesn't exist, reads it, finds the code blocks, enumerates it, and writes it. So this is it. I know it's, again, like I said, it's a bit hacky, but it was really exciting. I got this when I couldn't go to sleep the other night, and I just got up and put it together. It's really exciting. I think I want to work on this more and experiment and see how it goes. I hope you enjoyed this, and see you in the next video. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files, so you can get inspiration quickly. Another benefit is that you'll have access to all my courses, and my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.